So we will continue our studies with chapter 1, fluid properties. So before I go further, there are a few things that I need to present to you. I think this is just like a reminder on how to calculate a few things in fluid properties. Properties is characteristic, correct? So the characteristic of a fluid depends on a few properties, which is, for example, number one, we call it as density. I believe you already learned it last week, but this is just a revision from there. So density should be denoted as rho, okay? And it is equal to mass divided by volume. So it is m over v. Okay, my mass will be a small m. My volume will be a capital V with a dash over here. And then the unit for this should be simple, kilogram per meter cube. So this is density. All right. So the density itself depended on the type of properties we are using. Okay. For example, the properties of water or H2O, I just put it as water. The density for water should be equal to anyone?
1000
1,000 kilogram
kilogram.
per meter cube. Good. All right. So what about the density of oil? Can anyone tell me what's the number? Gas, for example. Don't worry, you don't have to Google it. Just a guess. If I put
1,300.
1,300. Okay. Before I go further with the numbers, so if you have water and oil mixed together in a cup like this, okay, for example, which one will be floating? Which one will be at the bottom?
The floating is the oil.
Good.
All will be floating, correct?
Floating. Yes.
Okay, so all will be floating and then water will be down here, correct? So this
Yes.
represents the idea of density. If it is denser, it means the number will be higher. So water is 1,000 over here. So it means that if you are talking about the density of oil, it should be lower than 1,000 because it is floating on top. All right. So if based on this one, the number for density for oil is actually around 700 to 800 kilogram per meter cube. Don't worry, you should not have this number in your head right now, supposedly, because the number is changing depending on the type of oil that you have. But normally, every single oil should be having a lower number of density compared to water all the time. That's why oil will always be on top of water. And that's why if you have a burning oil, for example, if you learn it from the firefighters, you should not cover the burning oil with water because the water will spread out, correct? The fire will spread out like wildly, okay? So what happened there is because oil and water does not mix, and then it's not a good or suitable way for you to switch off the fire, so it is not through water. Sebab dia tak mix, all right? So density of water will always be lower than the density of, higher than the density of oil. So if in case you have multiple fluid and you do not know what is the number for the density, so you just have to do this experiment. Just put it inside the same place like this, okay? And then you should be having a different condition over here where some fluid will be on top of the others. And then you just have to know which fluid is that, and you will know which one will have a lower density or higher density. Simple, that one. Okay, number two, the density is based on mass, but it based on volume also. So if you have the same mass, constant mass, but higher volume, okay, it means the density will be lower. Or if you have a bigger mass, but a smaller volume, the density will be higher, okay? So if we play around with the same mass, we change the volume, so we'll play a different type of density, okay? Number two, we call the property as specific volume. I go with this first. Okay, specific volume denoted like this. is equal to volume divided by mass. This is the other way around compared to density. Okay, it means it will be V over M, and the unit will be meter cube over kg. Okay, and this can also be equal to, because this is the other way around from density, it will be 1 over density. All right, so it's the same thing. It's either 1 over density or volume over mass. So this one depends on the mass and volume, the other way around like this. It means if you have a constant volume, but with a different mass, we'll have the idea of the specific volume. Okay, so these two, using the same mechanism, okay, but you have different denominators and nominators, and will provide you with a different answer because the unit also will be the other way around. Okay, so this will be specific volume. Okay, number 3, we will have a property called as specific weight. Okay, so specific weight, all right, the symbol is this one. I'm not sure what it is called. Usually we call this as any ksatria over here. I think this is gamma. Okay, so it is equal to density multiplied by gravitational acceleration. Okay, or the unit will be rho g, and the unit is Newton per meter cube. All right, so specific weight depends on the density and multiply with the gravitational acceleration, rho times g. Okay, how do I get Newton per meter cube? Because there's a second way to find out specific weight. It is equal to weight divided by volume. This is weight divided by volume. So weight should be in Newton, volume should be in meter cube. So that's why the unit over here is Newton per meter cube. All right, the unit should be the same, rho g or W over V should be Newton per meter cube also. Okay. Right, number 4 will be on specific gravity. Okay, so specific gravity denoted as Sg. So Sg is equal to the density of fluid of our study. For example, I have oil over here. I want to know what is the specific gravity. We compare it with the density of water. Okay, and you should know the density is 1000 kg per meter cube. So for example, if you are using oil over here, so Sg for oil is equal to the density of oil divided by the density of water. Or it is equal to, for example, I'm taking 700 divided by 1000 kg per meter cube, kg per meter cube. So Sg oil should equal to 0.7.
7.
No unit. Why?
Dah potong.
Because both of them are the same units, correct? So we cancel each other out, all right?
Yes.
So practically, these are the 4 fluid properties that you need to understand, and you need to know how to calculate things, because whenever we have to do studies on properties of fluid, we will use this number. Okay. Why is it important to learn about these fluid properties based on this equation? It's a very simple idea, because we don't want to do a lot of experiment over and over again. For example, a lot of experiment has been done by prior to our study over here. It's been done by researchers from before. So that's why I know that the density of oil is 700 or 800 kilogram per meter cube, because it was done by a lot of researchers before. So we do have the numbers. So we don't have to do experiment all the time. So each time you see, for example, specific gravity. For example, I have a fluid Sg equals to 0.3. It means 0.3, it means that the top part or nominator is lower than the denominator. That's why you have a 0 point something. So it means that the density of the fluid on top should be lower than the density of water. So water over here becomes like a benchmark for everything. So you know water, you use water every day, and we know the density is 1000 kilogram. The number is clearly stated, 1000, simple. So we can do comparison compared to water as an easy comparison, as a benchmark. Okay. So for example, if the SG is lower, it means the density of the fluid is lower than water. All right. And so on and so forth. Okay. So what's the highest density for a fluid that you can meet in this earth right now?
Mercury.
Mercury. All right. Good. So the density of mercury is around 13,600 kilogram per meter cube. Okay. 13,600 kilogram per meter cube. So this is the highest number for density for liquid that we have in our earth right now. Okay, 13,600 compared to water, 1,000 kilogram per meter cube. All right. Okay, so looking at that, I just want to know if you have water as 1,000 kilogram per meter cube, what is the weight of 1 liter of water, or the mass of it in kilogram? Anyone can answer?
Can you repeat, sir?
What is the mass of 1 liter of water in kilograms?
1 kilogram, sir.
How do you know it's 1 kilogram?
I'm guessing.
Guessing. Okay. The answer is correct. 1 liter of water is 1 kilogram of water. Okay. It means if you are carrying a box of water, if you want to know how much or what is the mass of it, just have to do calculation based on the liters, and then you will get kilos of water. So how do you get that numbers? Easy. The number comes from this calculation here, from row of water. So if you have row of water equals to 1000 kg per meter cube, okay, 1 meter cube equals to 1000 liters. All right. So you can see this is 1000 kilogram per meter cube. So 1 meter cube is 1000 liter. It means for every 1 liter of water, it is equal to 1 kilogram. All right. So that's a simple idea of it. All right. So you have 1000 liter of water here. So it is actually equal to 1000 kilogram. So it means 1 liter of water should be equal to 1 kilogram of water. All right. So that's the easiest part for it. Okay. Or if you want to change it through calculation, so it would be 1000 kg per meter cube multiplied by 1 meter cube is equal to 1000 liter. So this cancel out. So 1 kg per liter. All right. So any question on that? Okay. So each time, so if you have any calculations regarding water or anything, you should remember the number is 1000, and you need to know 1 meter cube is 1000 liter. This is a very important information in the future. Okay, based on this, any question?
No, I think no.
Simple, right?
I guess no.
I
Yes.
guess no, eh? Okay, now today is a guessing game. All right, okay, so that's the fluid properties. We are not done yet. We have another fluid properties that we need to know. This is based on the idea of, okay, let me change the color first. So this is based on the idea of ideal gas. All right, so before this, whatever that you learned before this can be used for gas, can be used for liquid. No problem, okay? However, there are some things that you need to know in terms of ideal gas because some of the calculation cannot be used for liquid and it's only for gas. So the calculation that we need to know here is based on ideal gas, and the equation from ideal gas that we need to use is based on this equation. PV equals to mRT, right? This one comes from physics, I guess. You should have the idea from physics, but just gonna remind you back. P is pressure. Pressure should be in Pascal. V is volume. Volume should be in meter cube. M is mass. Mass should be in kg. R is gas constant. Gas constant should be in terms of, let me see, gas constant, so PA m cube divided by kg K, right? And then T is temperature, and it should be in
Celsius.
Celsius, correct? No, it should be in Kelvin. Okay, no worry. If I ask you a question, just answer. If it's wrong, I will just give the right answer to you guys. Okay, we are used to Celsius, but we're supposed to learn it in terms of Kelvin. Okay, why do we use Celsius? Because it depends on the region. Here we use Celsius. If you go to the US, United States, they should be using Fahrenheit rather than Celsius. Okay, but the normal or the SI unit for temperature should be in Kelvin. Okay, how do you get Kelvin? Simple. Anything that you get in terms of Celsius, you add up to 73.15, then you will get the answer in Kelvin. For example, 30 degrees Celsius is equal to 303.15 Kelvin. Right? So that's the idea of it. Okay, so why do we need to know about ideal gas? Because in ideal gas, we will have some of the fluid properties that is important for our study. For example, we have volume here and we have mass. Remember, if you have volume, if you have mass, we should get density and specific volume. Alright. So we use ideal gas calculation when we are dealing with gas, first thing, and it involves pressure and also temperature. Okay, if you read out the questions after this, you will discover that some of the question is talking about gas, air, for example, and the gas itself is being given all the pressure and temperature related to it. So because of that, you need to change the calculation. You need to use this calculation first to find out about the volume and the mass, for example. All right, and because we only have one equation here, this should be having only one unknowns. So any questions that you have, you should only have one unknowns. Okay. Usually gas constant is given in the question. So don't worry. Use whatever number given to you in the question. Okay. And the one that will be unknowns might be the volume, might be the mass. Okay. Because P and T is required to calculate that. Okay. So how do we go with this? So I'll go and do a few equations related to this. So number one, if you have ideal gas, example PV equals to mRT. If you rearrange the equation, okay, for example, P M over V, this is volume, times RT. So you will discover that it is equal to rho RT. The definition is here. Density is equal to mass divided by volume. So if you want to find out what is the density based on the ideal gas, so it will become P over RT. So it's hard for you to differentiate. So let me put rho to be like this. Okay, so P pressure divided by R divided by T, you will get the density. Number two, it may look like this, PV equals to MRT, and we can rearrange it back to be V over M equals to RT. So V over M over here is specific volume. So it will become P specific volume equals to RT. So specific volume is equal to RT over P. All right. So I guess based on this equation here, you can change the equation to get in terms of density or in terms of specific volume. All right. So that will be the important properties that you need to know based on chapter 1. Okay, any question? No, eh? Still quite easy to understand or it's become harder? Not sure.
Okay, it's okay.
It's quite okay, right? It's quite okay in the morning, eh? All right, okay. So here, I'm giving you a calculation on fluid properties so that we'll get an idea on how to do things. Later on, I'll be giving you tutorials on this. And then please make sure you take your time at home and while watching TVs or handling your kids or your brother or sisters at home, you can try and do some calculation based on fluid properties. Okay, but right now, I'm giving you an example so that we have the same idea on the calculation. Okay, so this is example number 1, fluid properties. A closed rectangular tank has the dimension of 40 cm times 40 centimeters multiplied by 30 centimeters. If the tank is to be filled with a substance having a specific gravity of 0.2037, determine the density, the mass of substance, the specific volume, and the specific weight. Okay, based on this calculation, based on this question, we know that we have a substance getting into a rectangular tank, and we know the specific gravity is 0.2037. So we have a few information that will help us through this calculation. Okay, do you see any temperature or pressure here? No, right?
No.
No. No, okay. You don't see even about, they are talking about gas or air over here. So we can just assume we are not going to use the calculation on ideal gas. All right. Okay, so from here, we know the specific gravity, Sg, is equal to 0.2037. Based on this, like I said just now, you will know that this number is lower than 1. It means this is having a density lower than water. Okay, so how do you find out the density? Simple. Sg is 0.2037. It is equal to the density of the substance divided by density of water, which is density of the substance equals to 0.2037 multiplied by 1000. So the answer should be equal to 203.7 kg per meter cube. All right. So if you discover from this, we okay. Okay, so if you discover from this, the question will not be a simple, okay, we give you mass, we give you volume, and then you need to find out the density. It's not as simple as that. Sometimes they give you specific gravity, sometimes they give you in terms of weight, and many other ways, okay? So you just need to remember the equation so that we can manipulate any equation to find out what is asked in terms of the question. Okay. So number 2, the mass of substance must be added to the tank. All right. Mass of substance must be added to the tank. Okay. So we know the density. We should know the mass. So how do you know the mass? Because we have volume over here. So you need to find out what is the volume first. So volume over here should be equal to be easier, change it into meter all the way. So 0.4 multiplied by 0.4 multiplied by 0.3. I need your help to also calculate this with me because I forgot to bring my calculator today. I'm using my phone and it's not reliable. So I get around 0.048 meter cube.
Yeah, 0.048.
All right, 0.048 meter cube. Okay, so I know the volume. So from there, we know the density, we know the volume. So density is equal to mass divided by volume. So the mass is equal to density multiplied by the volume. Okay, so the mass of the substance should be equal to 9.776 kilogram. So 9.776 kilogram, right? Right, so this is the answer for question 1. This is the answer for question number 2. Okay, question number 3, the specific volume of substance in the tank. Okay, specific volume. It means we need to find out, okay, specific volume. This can also be 1 over density, or it can also be volume divided by mass. It depends on you. So if you have the density, it's easier to divide 1 over 203.7. So, or if you want to use V over M, you can do so. This. Okay, so it should be 4.909. Okay. Times 10 to the power of negative 3. So it should be in meter cube per kg. Right, and the last one will be the specific weight. So I put number 4 over here. Specific weight, sorry, wrong symbol. All right. Specific weight should be gamma equals to rho times g. So equals to 203.7 multiplied by g should be 9.81 meter per second square. So it should be equal to 1998.297. 1998.297 Newton per meter cube. Okay. So we have answered everything. Okay, any question on this particular example?
So, sir, question number
Alright.
3, we can choose either 1 over density or volume over mass lah.
Yes, correct. You can choose either one.
Okay, thank you,
You
sir.
should get the same answer. Might be different a bit on the numbers, but it's just a small deviation from the actual number. So you should choose anyone or anything that you want.
So which one is better? Is it a 1 over?
It depends on you. As long as you know the density, you can use 1 over density. If you know the volume and mass, you should do volume over mass. There will be a time sometimes when you don't know about the mass or the volume. So you should rely on the density that is given to you. So it depends.
Okay,
Right.
thank you, sir.
Okay. Right, so that will be covering the first example. I guess this is a simple one. Practically, if you are in a test or in your assignment, chapter 1, the calculation of fluid properties will be a simple calculation like this, okay? It's just a change of properties given to you and you have to react with that. Okay, this is a second example of fluid properties. If you read from the question, a large hot balloon contains helium, so it's a gas, having a weight of 1.49 times 10 to the power of 5 Newton, is measured under a standard atmospheric condition at pressure and temperature of 101 kilopascal and 15 degrees respectively. Determine the density of the helium, specific gravity, specific weight, volume, the mass of the helium in the hot balloon. Okay, so it's a question based on helium. So it's a gas. So we can consider using the either gas calculation. So this is why I asked you to check whether the question is using gas or using liquid or other gas without the temperature and pressure. So first, it's a gas and we have pressure and temperature. So it means we have to use the calculation for ideal gas. All right, first, how do you find out the density? Okay, hot balloon, we have the weight. We have the temperature also. We have the pressure over here. Okay, so first, before we go further with the calculation, please check on the gas constant here. All right, the gas constant over here is given to you in terms of joule, kg/k. So joule is actually energy. It is equal to right, or pressure times volume. Right, so joule is energy, okay, or work should be pressure times volume. Right, so the unit should be par dot m cube. So this one is kilopascal. It means we need to change it in terms of pascal when we are doing the calculation. If the unit over here is in terms of kilojoule, it means you can use the 101 all the way. But since in the unit over here, we are using joule, so it means we need to change this into 101,000 pascal because we don't want to have different units altogether. All right. To find out the density, so you need to know about density. First, we need to know what is the pressure. So we prep up our calculation by having pressure, P, Pascal, and then temperature should be 15 plus 273.15 equals to 15 plus 273.15, 288.15 Kelvin, right? And then we have weight to be equal to 1.49 times 10 to the power of 5 Newton. So if you want to find out what is the mass, should be weight divided by gravity. So 1.49 Okay, so the answer will be 15,188.58 kilogram. Actually, by doing this, I have answered question number 5. Okay, so this is question number 5 here, the mass of the helium in the hot balloon. All right, so it means any question that you have regarding fluid properties, it doesn't mean that you have to finish up number 1 first and then number 2. You don't have to follow the step by step. You might get the answer for number 5 first, then you get the answer for the others. All right. Okay, so M, you should get the mass of the equation here. All right, so by using ideal gas, what we can do is we can do PV equals to mRT. So pressure is 101,000. V is unknown. Okay, equals to mass 15,188 multiplied by the R 2077 multiplied by the temperature, which is 288.15. Okay, so volume is here. So these are the numbers. You should get the answer from there. For example, 101. Please calculate together with me. Because I'm clumsy with my calculator, sometimes I'm wrong. Okay, so the volume should equal to
Oi.
anyone gets the volume?
Oh. 15188 and 2000
Okay.
5 minus 1001 123. I figure
Okay, so the answer should be I get around 0.011. Is it the same?
No. Over
Or am I getting a different number here?
volume.
Oh. So the volume should be 15188.58 times 2077 times 288.15 divided by 101,000. So it should get around 90,000 for volume. Okay, the number is ridiculously high, but just go with it lah. All right, so meter cube. Okay, the answer here is 89,000. So it's a bit here and there, but I think represents the same idea, 90,000. So this actually covers question number 4. All right. And then from there, you can calculate your density. Okay, it's either you use this way or this method, or you can just do the method of getting the density from the ideal gas. It's the same thing. Okay. But let we do the number 1 first here. Since we know the volume and mass, so density equals to mass divided by volume should equal to 15,188.58 divided by the volume, which is 90,000. Okay, Sorry, I think some of you might get a different number than me because
Yeah.
I forgot to put 0.58 at the end here. Okay. All right. So what do you get for yours? If you don't have the 58 there?
8, 9, 9, 9, 8.
All right. So 899 something, correct? Don't worry.
Yes.
The number is quite there. It's okay. Okay. All right. So 15188.58 divided by 90,000. So the answer should be
1
0.688. Correct? So kg per meter cube. Almost there. We are halfway through. Number one is there. So the answer. And then the specific gravity, number two, should be just specific gravity, correct? So specific gravity should be Sg.
Acceptable kalau saya buat jawapan yang volume tu
Mm-hmm.
9.00 tapi darab 10 to the power of 4.
Yeah, it's acceptable. As long as you use the numbers correctly, it's acceptable. It represents the same thing. 9 times 10 to the power of 4 means 1, 2, 3, 4, correct? So 90,000 is 90,000. So it should be okay. But sometimes when you do calculation, it requires you to have the number to be a bit specific, especially when like this 89,975, 90,000. So usually if the number is not too long, okay, for example, the number is just like this, you can just use the numbers that we have here in terms of this number lah. And you do not multiply with a 10 to the power of something. It depends on you, okay? But if you do, for example here, 15,188, if you do 15.2, it means you are missing around 12, the number of 12 here. So it means your calculation here will change also. So try, for certain calculation, it's best for you to just stick with this number. And for a certain calculation later on in the semester, the numbers at the back might not be as useful as we have right now. Okay?
Okay.
All right. So number two will be specific gravity. So specific gravity is this, equals to rho g. So this should be equal to density 0.1688 multiplied by 9.81. So the answer is equal to 1.655.
1.655.
Sorry, this is specific weight. Oh, okay. I'm sorry. This is specific weight number 3. Okay. 1.655. Or 56. All right. So Newton per meter cube. Sorry, just now. And then lastly, we have specific gravity, Sg. Okay. It is the density of the helium divided by density of water. Should be the density of helium is 0.1688 divided by density of water 1000. So Sg will be a very small number. So 0.1688 times 10 to the power of negative 3. Okay, that should cover the question for today.